Hello everyone, today we're looking at measures of location of data. We're going to look a little bit at percentiles, and then we're going to focus on quartiles in this section. Percentiles divide data into percents, which, as a reminder, are 1/100ths. If I'm looking at the kth percentile, that's some value, and that means that k% of the values are equal to or less than that value, and 100 minus k%, or the remaining percent, of the data are equal to or greater than that value. So for instance, we're going to find the 30th percentile of the following values. One thing that you need to make sure of is that your values are in numerical order. So if they're not, put them in numerical order first. We also need to know how many values there are, and in this case there are 9. So what we do is we find 30% of 9, which is 0.3 times 9, which is 3. So if this equals a whole number, which it does, it's 3, then we find the mean of this value and the next value. And by this value, I mean the third value. So we look at the third value, which is 20, and we look at the next value, the fourth value, which is 24. We find the mean of those two numbers, and that's 22. Remember, mean is average, and to do that, I'm going to do 20 plus 24 divided by 2. Which is 22. It's also the same thing as the midpoint. The midpoint of 20 and 24 is 22. So 22 is the 30th percentile. As another example, let's find the 50th percentile. So 50% of 9 is 0.5 times 9, which is 4.5. This value is not an integer. And if it's not an integer, we use the value in the rounded up position. So 4.5 rounds up to 5, so we do the fifth value, which is 28. So 1, 2, 3, 4, 5, the 28th value. Half of the numbers are equal to or below 28, and half the numbers are equal to or above 28. So like I said, we're going to concern ourselves with what are called quartiles. Quartiles divide the data into quarters. And we just saw the 50th percentile. The 50th percentile is a very special one. It's called the median, which is sometimes denoted by M. It's also called the second quartile, which is Q sub 2. It separates the values into the top 50% and the bottom 50%. So Q1 is the 25th percentile, the first quarter, which is equal to the median of the lower half of the data. Q3 is the 75th percentile, or the third quarter, and that's the median of the upper half of the data. So we have some data, and we divide it into fourths. Here's Q1, Q2, Q3. So 25% of the data is over here, 25% here, 25% here, and 25% here. Okay, so that's what we're going to focus on. We also have what's called an interquartile range, usually denoted by IQR, and that's Q3 minus Q1, and it indicates how spread out the middle 50% of the data is. So again, if we go back to our dividing it into fourths, Q1 and Q3, so it's Q3 minus Q1. So it tells us how spread out the middle 50% of this is. And then the last thing we look at is what's called a potential outlier. And these are values in the data that are outside of the following range. Q1 minus 1.5 times the IQR to Q3 plus 1.5 times the IQR. So we'll see what this looks like in an actual example. So find the quartiles, the IQR, and identify any possible outliers from the following data set. So again, what you want to do is you want to make sure your data is in numerical order. So if you notice, it's going from smallest to largest. So always make sure that your data is in numerical order. Q2 is the midpoint. Remember that this is the 50th percentile. So we take n, which is 20, and we multiply it by 0.5. And that gives us 10. Since 10 is an integer, we look at the mean of the 10th and 11th values, which are 80 and 81. So we want to find the mean of 80 or 80 and 81, which again is just the midpoint. And halfway between 80 and 81 is 80.5. So 80.5 is Q2. So again, that splits the data in half. It doesn't have to be a value, right? 80.5 isn't one of our actual values, but half of the data is below 80.5 and half of the data is above 80.5. Next, we're going to find Q1. So Q1 is the midpoint or the median of the lower half of the data. So for Q1, I'm going to focus on these values. N is 10. So I take 10 and I multiply it by a half, because again, this is the median of this data set. I get 5. Again, 5 is an integer, so I'm going to take the median, the mean or the midpoint of the 5th and 6th values, which is 69 and 76. Halfway between 69 and 76, 72.5. For Q3, I'm going to look at the last half of the data set and find the median there. And again, there's 10 values. Halfway of 10 is 5. Again, that is an integer, so we're going to take the mean of the 5th and 6th data values, which are the 90 and 91. And if I take the midpoint or the mean of those two numbers, I get 90.5. So here are Q1, Q2, and Q3. The next thing I want is the IQR. That is, remember, Q3 minus Q1. So 90.5 minus 72.5. And that gives me 18. The last thing I want to do is find any possible outliers. So a possible outlier, remember, are just values that don't seem to relate to the other values. Numbers that are too big or too large, and there might be a reason for it. There also might not be. So that's why it's a possible outlier. We don't know why they're so much bigger or so much smaller. But again, to find the range, so we take Q1, which is 72.5, minus 1.5 IQR, the 18. That number up until Q3, 90.5, plus 1.5 times the IQR. If I simplify that, I have 45.5 to 117.5. So any possible outliers are going to be either below 45.5 or above 117.5. And if we look at our data set, 99 is the maximum, so that is inside our range, but 30 is outside of it. 30 is too small. So we have a possible outlier. Again, we don't know if it's an actual outlier or if it just happens to be that the values can be that low. So it really depends on what these numbers are coming from and then some type of intuition as to whether or not you think it's an actual outlier or not. And now we'll do the same for this data set. Again, notice that it's in numerical order already. The first thing we're going to do is count out our numbers. There are 20 of them. So to find Q2, I take 20, I multiply it by a half, that gives me 10. And again, 10 is an integer, so I'm going to look at the mean of the 10th and 11th values. And those happen to both be 80. So the mean, or the middle, of 80 and 80 is 80. So again, that splits up our values. Half are bigger or equal to 80 and half are smaller or equal to 80. So for Q1, we're going to look at this half of the data set, and there are 10 values there. So we cut that in half. Again, we get an integer, 5, so we look at the mean of the 5th and 6th values, which are 72 and 73. And the midpoint of those is 72.5. For Q3, we look at the upper half of the data. Again, there are 10 values. Divided by 2, we have 5, so we want the midpoint of the 5th and 6th values. The midpoint of 92 and 95, 93.5. Next comes the IQR. So again, that's Q3 minus Q1, which gives us 21. The range for possible outliers is again Q1 minus 1.5 IQR, all the way up to Q3 plus 1.5 IQR. And this gives us the range of 41 to 125. So if we want to find any possible outliers, those will be numbers that are either less than 41, which notice there aren't any, or bigger than 125. And again, there aren't any. So there are no possible outliers. Okay, so read through the book, try out the homework, and let me know if you have any questions. Good luck.